Hello and welcome back to the channel. In this video, we're going to be building a backend server that supports advanced filtering, sorting, and pagination, and we're going to be using the Mongoose library. Before watching this video, you should watch the previous video that we made on CRUD servers. Since we won't be covering the very basics in this video, I'll leave a link to the CRUD server video in the description below. So in this video, we're going to be building a CRUD database, and we're going to be applying filters, sorting, and pagination to the CRUDs we have in our database. To get started, we're going to first open our terminal. And we're going to create a folder for our project. I'm going to call it CRUD backend. And we're going to cd into that folder. And to initialize our node project, we're going to run the command npm init. And we're going to use all the default values. Once that's done, we should see the package.json file inside our folder. The next thing we're going to do is install our dependencies. So to install dependencies, we're going to use the npm install command. And the dependencies we're going to be using in this video are Express. We're going to be using Express to set up our server. We're also going to have .env. This is going to be used to store private information. We're also going to have Mongoose, which is going to let us communicate with MongoDB. And finally, we're going to have a new library that we have not used before, which is Express async errors. Now this library is going to automatically handle our try-catch blocks, and we're going to see how it works later on. And we're going to press enter. Once that's done, we're also going to have a dev dependency. So we're going to have npm install, and the dev dependency is going to be nodemon, which is going to be used to restart our server whenever we make changes. And we're going to add the option save dev. If all the commands completed successfully, if we go to the package.json file, under dependencies, you should see all the dependencies we've installed. You should also see nodemon under dev dependencies. One last thing we're going to do inside package.json is add a script. So we're going to add dev, and the value is going to be nodemon index.js. So when we run npm run dev, it's going to open up our server using nodemon. Once that's done, we're going to save this file. The next step is going to be creating our entry point. So inside our backend folder, we're going to create a new file, and we defined our entry point as index.js. So we're going to have index.js. At the top of our file, we're going to require the Express async errors library. So what this is going to do is, once we've defined it in our entry point, later on when we define our async functions, we're not going to be required to define a try-catch block. This middleware is automatically going to cache the errors, and it's going to pass it to Express's error handler. Next, we're going to import Express. So we're going to have const express, and we're going to require Express. Then we're going to create our Express server. So we're going to have const app equals Express. In the previous video, we saw that we can refactor our code into different folders. So this time we're going to start with the refactored version. If this is confusing, you should go back to the previous video, since in that video we started by writing all our code inside the index.js file, and then we refactored it. So in our refactored version, we're going to have two folders. The first is going to be routes, and the second is going to be controllers. So inside the routes folder, we're going to create a new file, and we're going to call it cars.js. And inside this file, we're going to define our different endpoints. So the first thing we need to do is import Express. Then we're going to create our router. So we're going to have const router, and we're going to use express.router. Now using this router, we can define our different endpoints. In this project, we're only going to have one endpoint, which is going to get all our cars, and we're going to be applying the different filters to this endpoint. So we're going to have router.get, and it's going to only have a slash, since we're going to be defining the first part of our path, which is /API/v1 inside our index.js file. And whenever the user goes to this path, we're going to have a function. Now this function is going to be refactored into our controllers folder, and we're going to call the function getAllCars. Now we haven't defined this function yet, so we're going to head to our controllers folder, and we're going to create a new file called cars.js, and in here we're going to define that callback function. So we're going to have getAllCars. It's going to take in rec and res. And for now, to test it out, we're simply going to respond with a message that says hello world. Next, we need to export this function. So we're going to have module.exports, and we're going to set it equal to getAllCars. Now back in our routes folder, we need to import this function. So we're going to have const getAllCars, and we're going to set it equal to require, and we're going to pass in the path to our controller. And once we have our controller, we need to export our router so we can use it in our index.js file. So we're going to have module.exports, and we're going to pass in router. And we're going to save this file and head back to index.js. Now in here, we're going to import our router. So we're going to have const router, and we're going to require the path to our router. Once we have our router, we're going to use the app.use function. So we're going to have app.use, and our base path is going to be /API/v1/cars, and we're going to use the router. Now, if the user goes to a path or endpoint that we have not defined, we can handle it using a custom middleware. And to do that, under our route, we're going to have app.use, and we're going to pass in not found. Now we have not defined this middleware yet, so we're going to define it now. We're going to create a new folder called middlewares, and we're going to create a new file called notfound.js. Now this is going to be a simple function that is going to display a custom message if the user goes to an endpoint that we have not defined. So we're going to have const notfound, which is going to take in request and response. Now if this middleware was not going to send a response, we would have to define the next parameter and pass the control to the next middleware. But in our case, the notfound middleware is going to return a response, so we don't need the next function. And inside our notfound middleware, we're going to respond with a status of 404. And we're going to send a message that says path not defined. Now we can export this middleware. So we're going to have module.exports, and we're going to set it to not found. And back in our index.js file, we're going to import not found. Now the final thing we need to do before running our server is defining app.listen. So app.listen is going to take in a port number. Now if you're going to be deploying this application, the service you're going to use might define its own port number inside its environment variables. So what you can do is set port to be process.env.port or 3000. So what this means is if process.env.port is defined, we're going to use that port. And if it's not defined, we're going to use 3000. Another thing we should do is require the .env package. So we're going to have .env, and we're going to call the config function. Now we can save our file and head to the terminal. To run our server using NodeMon, we're going to use the shortcut npm run dev. And we're going to head to the Postman extension to see if our server is properly running. So we're going to open Postman, and we're going to click on New HTTP Request. And the path we're going to test is http://localhost. The port number is going to be 3000. And first we're going to test the /API/v1/cars path. So if our server is properly working, we should get hello world sent back. If we see our response, we're actually not sending the request properly. So we're going to head back to our index.js file. And the problem is that we have not passed in our port. So we're going to pass in port, and we're going to save the file. And we're going to head back to Postman. And now if we send our request, we can see that we have hello world returned. And one more thing we can test is if the user goes to a path that we have not defined, like /hello, and if they send a request, we get our custom message, which is path not found or path not defined. So now that our server is working properly, the next step is going to be connecting to our database. The first thing we need is getting our Mongo URI. So we saw how to do that in the previous video, but I'm going to show it to you again. So you're going to open up your browser, and we're going to search for MongoDB Atlas, and we're going to open the first link. If you don't have an account, you're going to click Get Started, but if you have an account, you're going to sign in. If you're creating an account for the first time, you're going to be prompted to create a new cluster. So you're going to create a new cluster using the free version. Once your cluster has been created, you're going to set up two options. The first is going to be network access. What you need to do here is add a new IP address, and there's going to be a checkbox that allows your database to be accessed from anywhere. You're going to check that and add it to your IP access list. Another thing you need to set up is the database access. So in here, you're going to create a new database user. You're going to give it the following roles, which is read, write any database, and you're going to give it a password and a username. Now you need to keep track of this password since we're going to be using it in our Mongo URI. Once that's all set up, you're going to head to your cluster, and you're going to click on Connect, Drivers. We're going to pick Mongoose, and we're going to get the following link. So we're going to copy this and head back to our code. And inside our project folder, we're going to create a new file called .env. And in here, we're going to have the key Mongo URI. And for the value, we're going to paste in the link we just copied. Now in here, instead of db_password, you're going to put in your own password. And to give our database a name, we can provide it inside the / and question mark. In our case, we're going to call it cars database. Once you've entered your password, we're going to head back to our code. So as we did in the previous video, to connect to our database, we're going to create a new file. And we're going to call it connect.js. Since we're going to be using the Mongoose library, we're going to import Mongoose. Next, we're going to define a new function called connectDB, which is going to take in a URL, and it's going to connect to that URL using mongoose.connect. And we're going to return this promise so we can handle it in our index.js file. Finally, we're going to export the function. So we're going to have module.exports, and we're going to have connectDB. So we're going to save this file and head back to index.js. In here, we're going to first import the function. So we're going to have connect db, and we're going to require /connect. Inside our index.js file, since we want to connect to the database before we start up our server, what we're going to do is define a new function called start. Now, since we're going to be handling promises, we're going to set up this function as async. So inside our start function, we're actually going to have a try-catch block. Now, if you remember, we said if we imported the Express async errors library, we don't need to define try-catch blocks. But one thing you should keep in mind is that the Express async errors only works for request response cycles inside Express. But in our case, since we're going to be connecting to a database, it's not going to be able to handle the errors. So we need to define a try-catch block. Inside our try block, we're going to first await for the connectDB function. And we're going to pass in process.env our MongoDB URI. And once that's successful, we're going to log database connected. And only if our database connects successfully, we want to start up our server. So we're going to have app.listen, and we're going to pass in our port. And we're also going to add a callback function that is going to log server started. Next, we're going to define our catch block, which is simply going to catch the error, and it's going to log it. Next, we're going to remove the app.listen outside our function, and we're going to move our port to the top. Once that's done, we're going to call our start function. Now, if we save our file, and if we look at our terminal, we can see that we have database connected and server started. The next step is going to be creating our model. So we're going to head to our project, and we're going to create a new folder. We're going to call it models, and we're going to create a new file called car.js. And in here, first, we're going to import Mongoose. The next thing we're going to do is define our schema, which is basically the structure of each car. So we're going to have car schema, and we're going to set it equal to a new instance of mongoose.schema, and we're going to pass in an object. So the first attribute we're going to have is name, and its type is going to be string. Now you can apply different restrictions, but in our case, we're simply going to pass in string. Next, we're going to have price, which is going to be of type number. Then we're going to have a featured attribute, which is either going to be true or false. So it's going to be of type Boolean. Then we're going to have a rating attribute, which is going to be of type number. And finally, we're going to have a company attribute. Now for the company, it's going to be out of a certain list of options. And in order to define that, we're going to set it equal to an object. The type is still going to be string, but we can define another key value pair, which is enum. And this is going to be set to an object again, and we can define the different values. Values is going to be an array of the possible companies that we're going to have. In our case, we're going to have Tesla, BMW, Toyota, and finally Audi. So the companies that we're going to be adding to our database is going to be out of these values. And what we can do is define another property called message. And this message is going to be returned if the user enters a company that we have not defined. So what we can do is set the message to value inside curly braces is not supported. So this value is going to be replaced to whatever the user has entered. Once we've defined our schema, we're going to export it. So we're going to have module.exports, and we're going to create a model. So we're going to have mongoose.model, And here we're going to pass in what an individual object in our database is going to be called. In our case, it's going to be car. And Mongoose is going to take this and it's going to convert it into lowercase and add an S at the end. And that is going to be the name of our collection. So our collection is going to be cars. And a collection is similar to a table in a relational database. And the second argument is going to be our schema. Now currently our database is going to be empty. So the next thing we're going to do before applying the advanced filtering is we're going to populate our database. And to do that automatically, we're going to create a new file. We're going to call it populate.js. And since we're going to be using our model, we're going to import it. So we're going to have const car, and we're going to require from the models folder and the car file. In here, we're going to have an array of cars. So we're going to call it cars, and it's going to be an array. So for the list of cars, I'm going to be putting them in the description below, so you can copy and paste them. So this is the array of our cars. And if we look at the attributes, it's going to match to the schema we defined. We're going to have a name, a price, a featured, a rating, and a company out of the options that we gave it, which was Tesla, Toyota, BMW, and Audi. So once we have our list, we're going to scroll down. And we're going to define a function called populate. Since we're going to be dealing with promises, we're going to set it up as async. Now at the top of our file, we need to import different components. The first thing we need is the .env package, since we're going to be accessing our Mongo URI. And the other thing we need is our connectDB function, which is inside the connect.js file. Once we have those imported, we're going to head back to our function. And we're going to have our try-catch block. And the first thing we're going to wait for is the connectDB function. And we're going to pass in our Mongo URI. Once we've connected to our database, the next thing we're going to do is use the create function from our model. So we're going to have car.create. Now previously we used the create function to create an individual object, but we can also pass in an array, and it's going to create an individual item for each object inside the array. So we're going to pass in our cars array, and next we're going to log cars added, so we know that the process has finished successfully. And finally, to exit out of our program, we're going to run process.exit, and we can pass in a number. We're going to pass in 0, which means successful. Then we're going to have our catch block, which is going to catch an error, and it's going to log it. Once that's done, we're going to call our function, which was populate, and we're going to save this file. Now what we need to do is head to our terminal. And for now, we're going to stop our server. And what we need to do is run our populate.js file. So in order to do that, we're going to have node. And we're going to pass in the name of our file, which was populate.js. We're actually getting an error that is related to the second argument of our model. So we're going to head to our car.js file inside the models folder. And the problem is that the function name is not model with a capital M, but a small m. So we're going to save this file and head back to the terminal. And we're going to run node populate.js again. And we get the message cars added. Now to verify that the cars have been added, we're going to head to MongoDB Atlas. And we're going to click on Browse Collections. And as you can see, 20 objects have been added to our cars database. So that means all the cars have been successfully added to our database. So now we can go back to our code. And inside our terminal, we're going to start up our server again using npm run dev. And now we can get into the advanced filtering. So the remaining part of this project is going to be inside the controllers folder inside the cars.js file. So we're going to head over to that file. So to apply filtering to our endpoints, we're going to be using query parameters. Query parameters are key value pairs that the user enters, and we can extract them from the request object. So what that would look like is if we had the link http localhost 3000, and for our example, our path is /API/v1/cars. How a query parameter works is first the user enters a question mark, then they provide key value pairs. For example, they can say name equals ABC. So now we are going to get access to this key value pair inside our request object using request.query. They can also define multiple query parameters using end. So they could have end and say price is equal to 1,000. So that is how a user can send a query parameter. Now to see what this looks like, what we can do is inside our controller function, we're going to send back request.query. So now if we save this file and we're going to head to Postman and we're going to enter our path, which is /API/v1/cars, and we're going to define parameters. So we're going to have question mark, and let's use the previous example. So we're going to have name equals ABC and price equals 1,000. So now if we send this request, we can see that this is what the request.query object looks like. So we're going to have the key and the value. So we're going to be using this property to filter the cars in our database. Now, since this function is going to be dealing with promises, we're going to define it as async. Inside the function, we don't need to define our try-catch blocks since we're using express async errors. So the first filter we're going to be looking at is allowing the user to filter the featured cars. So that would be the cars that have the featured property set to true. So the first thing we need to do is extract featured from the request.query. So if the user enters featured equals true, we're going to get true. And if they enter featured equals false, we're going to get false. The next thing we're going to define is something called a query object. And initially, we're going to set it equal to an empty object. So how we're going to be using this object is inside our model. So our model is car. We have the find function. And inside the find function, we can pass in different properties. So if we passed in featured is true, then this is going to find all the cars with featured set to true. And if featured is false, it's going to find all the cars that are not featured. So what we're going to be making is inside the query object, we're going to have different properties and the value that the user has entered. And finally, we're going to pass this query object to our find function. So before we do all that, we need to import our model. So we're going to have car, and we're going to require from the models folder, the car file. Another thing we have to handle is the featured attribute may or may not be defined by the user. So to check if the user has included the featured attribute inside the path, what we can do is have a simple if condition, and we're going to pass in featured. So this means featured is defined. And inside the if statement, we're going to be building our query object. So inside our query object, we're going to add a new key called featured. And for the value, we're going to set it equal to true or false. So if featured is equal to true, then we're going to set it to true, else we're going to set it to false. Once we have our query object, we can use the find function. So we're going to await car.find, and we're going to pass in our query object. And whatever is returned, we're going to store it in a variable called cars. Once we have our cars, we're going to send a response with the status of 200, which means successful. And we're going to respond with a JSON. And for the JSON, we're going to pass in two attributes. The first is going to be the number of hits. Number of hits is going to represent the number of objects that match our filter. So if we had 10 featured cars, number of hits would be 10. And to access this number, we can simply pass in the length of our array. And the second attribute is going to be the actual cars, so we can pass in cars. So once that's done, we're going to save this file, and we're going to head to Postman to test this out. So now if we send a GET request without any filters, we're going to get all the cars returned. We can see that by the number of hits, since we have 20 cars in our database. But now what we can do is inside our URL, we can add a question mark followed by featured, set to true, for example. And now if we send this request, we can see our number of hits has decreased to 11. And if we see the cars that have been returned, their featured value is set to true. So we can go back to our code. So here what is happening is if the user has not defined featured, to our find function, we're passing in an empty object, which is similar to applying no filters and returning every object. The second filter we're going to be applying is a filter based on name. So what we want to do is if the user enters, let's say name equals A, we want to return all the cars that have A inside their name. So to do that, first we're going to extract name from our query parameter. Then we're going to check if name has been provided by the user. And to accomplish the functionality that we want, we need to use regular expressions. So regular expressions are used to match a certain pattern inside JavaScript. So in our case, we're going to first build our query object. So we're going to have query object, and the key is going to be name. And for the value, we're going to actually pass in another object. Now the syntax might be a bit confusing, but what you can do is go to the documentation of Mongoose, and you should be able to find how to pass regular expressions. So what we're going to do is have a $sign followed by regex. And for the value, we're going to give it name, which is the name that the user has entered. And we can also provide different options. For example, we can provide an option, I. What I means is it's going to make it case insensitive. So if the user enters a small a or a capital A, they're going to get the same results. So once we've built our query object, it's going to get passed to our find function. And the find function is going to return the cars that match the filters that we provide. So we're going to save this file and head back to Postman. And here, instead of featured, we're going to pass in name and let's say A. And now if we send this request, we get 6 hits. So these 6 cars are the ones that contain A inside their name. What we can also do is concatenate different filters. So what we can have is and we can provide another filter. So in our case, we define the featured filter. So if we set featured to true, this request is going to return all the cars that have A inside their name and also have the featured attribute set to true. So if we send our request, we only get 3 cars. So these cars are going to contain A inside their name, and they're also going to be featured. Another common functionality we can apply to our endpoint is sorting. To add sorting functionality to our endpoints, it's going to be a bit different from the name and featured attributes. So how our endpoint is going to look like is going to be the following. So we're going to have HTTP localhost 3000 API v1 cars, and how we want our sorting to work is the user is going to have the sort key, and they're going to set it equal to the properties they want to sort by. So for example, if they want to sort by name, they would pass in name. If they want to sort by price, they would pass in price. And they can also pass in multiple values. So how that would work is, let's say they wanted to sort by name, but if 2 cars have the same name, then if they want to sort by price, they can add a comma and put in the second attribute. So this is going to sort the cars by name first, then by price. So this is how the user is going to send us the attributes they want to sort by. The first thing we're going to do is extract sort from our query parameter. Now how Mongoose works is if we want to sort based on a certain attribute, we need to append the .sort function to our .find function. But in order for this to work properly, there is a bit of manipulating that we have to do. So what we want to do is first, we're going to find all the cars that match our query object. Then only after that, we want to apply the sort functionality. And in order to do that, we're going to remove sort from here. We're also going to remove the await keyword. And we're going to rename this variable to let results. And after we get the results, we're going to have our if statement that is going to check if the user has entered the sort filter. So if they have, what we're going to do is call results.sort. So instead of results, you can imagine that car.find is going to get substituted. So we're going to have car.find.sort. And the syntax that the sort function takes is attributes separated by a space. But in our case, since we're going to be getting the attributes from our path, they're going to be separated by commas. So what we can do is we're going to split up the sort attributes that the user has provided. We're going to split them up using a comma, and we're going to join them back using a space. So if the user enters name, price, we're going to pass to the sort function name space price. Now you may be wondering why we removed the await keyword. Now the problem is, in order to use the .sort function, it needs to be appended directly to a model. Now if we used await here, we won't be having the model. Instead, we're going to be having the result that we get from the find function. And to the result, we won't be able to append .sort. So what we're doing here is before sending this statement to the database, if sort is defined, we're going to first append it. So once we've applied the sorting functionality, what we can do is create a variable called cars, and we're going to wait for results. So after the sorting has been applied, we can send the statement to our database, and we're going to wait for the result, and we're going to send back our response. So now we can save our file and head to Postman. And in our URL, we're going to pass in the sort attribute. And let's say we give it price. Now if we send this request, now if we look at the price of each car, we can see that this is the lowest price. Then it's slowly going to be increasing the price. Now to actually see this better, we can open up our URL inside the browser. So we're going to open our browser. So inside our browser, we've added the sort functionality and we've passed in price. So if we look at the price, it's going to be in increasing order. Now thanks to Mongoose, since we're using the built-in sort functionality, we can also invert the sorting. So what we can do is instead of price, we can pass in minus price. And now if we look at our result, it's going to be sorted in decreasing order. So this is going to be the most expensive car. And at the bottom, we're going to get the cheapest car. Again, we can apply different filters at the same time. So here we can add and we can set featured equals to true. And now we're going to get 11 cars with featured equals to true. And they're going to be sorted in decreasing order of their price. Another common functionality APIs have is the ability to select only specific fields. So in our database, the user might only want the price of the cars and the name of the cars. So they should be able to filter them using our endpoint. Now this is going to work similar to the sort functionality. So Mongoose has a built-in select function. So it's going to be .select. And this is going to take in attributes separated by a space similar to sort. And it's going to return only those attributes. So what we're going to do is first, we're going to go to our query parameter and we can give it whatever name we want. In our case, to match the function inside Mongoose, we're going to give it select, but you can give it any name you want. And after our sort, we're going to have if. So if select has been defined by the user, we're going to have results.select. And again, the user is going to give us a comma separated list of attributes, and we need to change them into a space separated list of attributes. So we're going to have select.split. We're going to pass in a comma, and we're going to join them back using a space. Now in our sort functionality, we actually forgot to set results back to our new sorted results. However, we did not run into any issues. That is because the .sort function is going to be mutating the results object, and it's not going to be creating a new object. But for clarity and for readability, we're going to add results equals before we apply the filtering. So to test this out, we're going to save the file and head to the browser. So in our URL, we're going to select the name and price attribute. And now if we press enter, we can see that the result we get back is only going to include the name and price. It's also going to include the ID, but we're going to ignore that. So this is how you select a specific attribute. Again, we can chain this. So we can have end, and we can pass in featured equals true. Then it's going to return the 11 cars that have featured equal to true, and it's only going to return the name and price attribute. The next functionality we're going to be implementing is pagination. Now currently in our database, we only have 20 cars, but if we imagine that we had thousands or even millions, it's going to be inefficient to give the user all the results at once. So the user is going to be able to access the cars in pages. To apply this functionality, we need two values from the user. The first is going to be the page number, and the second is going to be the limit. So the limit is going to control how many items are going to be displayed per page. So if the limit is 10, one page is going to contain 10 items, and the user can control the page number to access the different items. So before we return our results, we're going to define a page variable, and we're going to set it equal to request.query.page. Here we're directly accessing the page attribute. So this is going to be the page that the user provides. We're also going to get the limit. Now these attributes may or may not be defined by the user. So what we can do is set a default value. To set a default value, we can use the OR operator. So if the page is defined by the user, we're going to use that number. But if it's not, we're going to use 1 as the default. And we're going to do the same for the limit. If the user defines a limit, we're going to use that limit. But if they don't, by default, we're going to use 10. One more thing we need to do is, since query parameters are strings by default, we need to convert them to numbers. Next, we're going to perform a simple calculation. So we're going to have a variable called skip, and we're going to set it equal to page minus 1 times our limit. So how this is going to work is, let's say page is equal to 1. 1 minus 1 is going to be 0, and 0 times the limit is going to be equal to 0. So if page is 1, we're going to skip 0 items, and we're going to display the first 10 items. And let's say page is 2, so it's going to be 2 minus 1, which is 1, times our limit. By default it's 10, so we're going to use 10. Then our skip value is going to be equal to 10. So if the user enters 2 for the page, then we're going to skip 10 items. And by skipping 10 items, what we're basically doing is accessing the second page. Let's look at this one more time. If page is 3, 3 minus 1 would be 2. 2 times our limit. If our limit is 10, that is going to be 20. So if our page is 3, we're going to skip 20 items, and that is going to be the same as accessing our third page. So this is how our pagination is going to work. And to apply the limit and the skip value, we're going to use results, and we're going to set them to results .skip, and we're going to pass in our skip value. And we're also going to pass in .limit, and we're going to pass in our limit value. Now we can save this file and head to the browser. So to see how the pagination works, to our URL, first we're going to simply apply a sorting based on price. So as you can see, we only get 10 items. That is because our default limit is set to 10. So we're going to get the first 10 cheapest cars. Now to access the remaining 10 cars, what we can do is set our page equal to 2. So now we get the remaining 10 cars. What we can also do is set the custom limit. So we can set the limit to 2, for example. And now our limit is set to 2. Now to get the 2 cars that are the cheapest, we can set the page to 1. And we're going to get the 2 cheapest cars. Now together with the page and limit, we can also pass in other filtering attributes. For example, we can pass in select and we can give a name. And now we get the 2 cars with their name only being displayed. The final filtering we're going to be applying is numeric filters. Now numeric filters are going to be a bit more complicated than the other filters, so make sure to follow along carefully. The first thing we're going to do is extract numeric filters from the query parameters. So how the user is going to give us these filters is going to be as follows. So they're going to set numeric filters, and they're going to have an equal sign, and they're going to pass in a property. In our case, the only properties that are numeric are price and rating. So if they wanted a price that is less than 10K, they would pass in price less than 10K. And if they wanted an additional numeric filter, they would add a comma. And let's say they wanted a rating of 3.5 or higher. So this is how the user is going to pass in our numeric filters. So what we're going to do is we're going to have our if condition. So we're going to check if numeric filters are defined. Now the first thing we need to do is we need to convert the human readable operators into something that Mongoose can understand. So if the user enters a greater than sign, if we pass this directly to Mongoose, it's not going to be able to understand it. Instead, we need to pass in $GT. It's going to be similar for the less than sign. Mongoose is going to be expecting $LT and so on. So what we're going to do first is we're going to define a map that is going to map from the user readable value to what Mongoose understands. So we're going to have operator map, and it's going to be an object, and the keys are going to be the user readable operators. So we're going to have greater than, and for the Mongoose side, we're going to pass in $GT. We're going to have less than, and for the Mongoose side, we're going to have $LT. Then we're going to have equals. For the Mongoose side, we're going to have $EQ. Then we're going to have less than or equal to. And on the other side, we're going to have LTE. And finally, we're going to have greater than or equal to. And on the other side, we're going to have GTE. So this is going to convert the human readable into something that Mongoose can understand. Next, we're going to define a regular expression. Now you don't need to memorize this, you can simply copy and paste it. So what this is going to do is it's going to match all the human readable operators. So the regular expression is going to be \b followed by a greater than sign, a less than sign, a greater than or equal to sign, a less than or equal to sign, and an equal to sign, and another \b, and we're going to apply the global flag. So this regular expression is going to match the user readable operators. And using this regular expression, we're going to update what the user enters, and we're going to replace the user readable operators with what Mongoose can understand. So to do that, we're going to create a variable called filters, and we're going to give it the numeric filters that the user has entered. and we're going to use the replace function. So the replace function is going to take in a regular expression. So we're going to give it regex. And as a second argument, it can take a callback function. And the callback function is going to take in a match as input. So match is going to exist whenever this regular expression matches with whatever the user enters. So when the user enters a human readable operator, we're going to get it inside the match parameter. So what we want to do is we want to return a template string. We're going to have a hyphen, then we're going to substitute operator map. So this is going to be the map that we defined earlier. And for the key, we're going to pass in our match. And at the end, we're going to add another hyphen. So what this is going to do is if it gets a, let's say, greater than or equal to character from the user, it's going to go and replace it with hyphen. It's going to replace it with hyphen, $GTE, and another hyphen. Now we're going to be using these hyphens later on to divide our expression. Once we have our updated filters, the next thing we're going to define is our options. So in our case, our options are only going to be price and rating, since only those two attributes have a numeric value. Once we've defined our options, we're going to have filters, and we're going to set it equal to filters.split, and we're going to split them by a comma. The reason we're doing this is, as we said before, the numeric filters that the user is going to provide is going to be comma separated. So if they want price greater than 30 and rating greater than 5, they're going to separate it using a comma. So that is why we're going to split the expression by a comma. And we're going to append the for each function, which is going to give us each item. And in here, we're going to again split each item using the hyphen that we previously defined. So now this numeric filter, after we've applied the regular expression, is going to get updated to hyphen $GT hyphen, and the rating is going to be updated to rating hyphen $GT hyphen. So the for each is going to give us each item. Each item is going to be price hyphen GT hyphen 30. That is going to be one item. And rating hyphen GT hyphen 5 is going to be another item. So we're going to be splitting the item using the hyphens. So we're going to get three values. The first is going to be the field. The second is going to be the operation. And the third is going to be the value. Now we can directly access them using destructuring. So we're going to have const. Since this is an array, we're going to use an array. And we're going to get the field, the operator, and the value. And once we have those three values, we're going to check if the field that the user has entered is inside our options. If the user enters a non-numeric field, we do not want to be applying this filter. So what we're going to do is we're going to check if options.includes, and we're going to pass in the field. So if the field is inside our options, what we're going to do is update our query object. The key is going to be the field. And for the value, we're going to pass in another object. And the key is going to be the operator, which is the operator that Mongoose can understand. And the value is going to be the value that the user has entered. One more thing we need to do is, since this value is going to be of type string, we need to convert it into a number. Before we head to the browser, one mistake we need to update is instead of .field, which is going to literally create a key called field, instead we need to use the square bracket notation, which is going to replace field with the field that the user has provided. Now we can save our file and head to the browser. Inside our URL, we can pass in a numeric filter, and we're going to set it equal to price. And let's say price is greater than 70K. and if we press enter, we're going to get 2 cars whose price are greater than 70K. We can also apply an additional numeric filter, so we can have rating greater than 4.8, and if we press enter, we're only going to get 1 car whose price is greater than 70K and whose rating is greater than 4.8. So this is going to be the end of our project. If you want the full code, I'll be putting it in the description below. And if you have any questions, you can put them in the comment section. For this project, we won't be building a front end, but as a challenge, what you can do is at the root of our backend, you can add information on how to use our API and what type of query parameters the user has to pass in order to use our backend. Thank you for watching this video, and don't forget to like the video and subscribe to our channel for more programming content.